This lesson is on solving quadratics by factoring. So before you start this lesson, make sure that you're familiar with how to factor quadratic expressions and equations. So the first thing we have to do is make sure everything is on the left side of the equal sign. Then we're going to factor the equation or expression, and then we're going to set each factor equal to 0 and solve for x. If there is a GCF, just forget it. You do not have to set that part equal to 0, only the parts that are inside the parentheses. So let's work on this example on the right. N squared plus 8n equals negative 15. First thing I have to do is get everything on the left or together. So n squared plus 8n plus 15 equals 0. And now I can factor this. So a equals 1. So I'm just looking for factors of 15 that add up to equal 8. So if I look at 15, its factors are 1 and 15, 3 and 5, negative 1 and negative 15, and negative 3 and negative 5. All of those will multiply together to give me positive 15. The ones that add to give me positive 8 are 3 and 5. So this becomes n plus 3 times n plus 5. So now I've factored it. The next step is to set them equal to 0 and solve. So n plus 3 equals 0, n plus 5 equals 0. So n can equal negative 3, and n can equal negative 5. And the reason that you get two solutions is because when we graph a quadratic, it's going to look like this and make a U shape. So the solutions represent where it crosses the x-axis, which is going to happen twice for a quadratic. So you'll have two solutions. So here we can work through a couple other examples. In this first example, I noticed that a is 8, which means that I'm going to have to do a little work before I can just straight up factor. So 8 times 9 is 72. And I'm looking for factors of 72 that add up to equal 18. So if I'm looking for factors of 72, I've got 1 and 72, 2 and 36, 3 and 24, 4 and 18, 6 and 12, and 8 and 9. And I also can make all of those negatives. So negative 1, negative 72, negative 2, negative 36, negative 3, negative 24, negative 4, negative 18, negative 6, negative 12, and negative 8 and negative 9. And what I'm looking for is the ones that are going to add up to give me positive 18, which is going to be positive 6 and positive 12. So I'm going to rewrite this as 8x squared plus 6x plus 12x plus 9. And this is sometimes called factoring by grouping. We referred to this as factoring when a is greater than 1 when we did our lesson on factoring. So I'm going to divide this in half and factor each side. So on this side, on the left side, I can pull out 2x, and I get 4x plus 3. And on the right side, I can pull out 3, positive 3, and I get 4x plus 3. Notice how we want the stuff inside the parentheses to match because we're only going to use that once. So the factored form of this is 2x plus 3 and 4x plus 3. So now I have factored it. My next step is to set them equal to 0 and solve. So 2x plus 3 equals 0. 4x plus 3 equals 0. And now I'm just going to solve for x. So x can equal negative 3 over 2, but remember quadratics have two solutions. So x can also equal negative 3 over 4. So these would be my two solutions for that quadratic equation. In the next example, I have something I have to move to the left, so I'm going to subtract 6, and I'm left with n squared plus 3n minus 18 equals 0. Now I can factor it. My a equals 1, so I'm just going to factor it as normal. I'm looking for factors of negative 18 that add up to give me positive 3. So I have negative 1 and 18, negative 2 and 9, negative 3 and 6, or I can switch them around. 1 and negative 18, 2 and negative 9, 3 and negative 6. And I'm looking for the ones that are going to add up to give me positive 3. So that would be negative 3 and positive 6. So this becomes n plus 6 and n minus 3. And I'm going to set them both equal to 0. So n plus 6 equals 0, n minus 3 equals 0, and solve. So n can either equal negative 6 or n can equal positive 3. Now I want you to try these problems on your own, and then we'll go over them. So in the first one, we're just going to factor like normal. So factors of 2 that give me positive 3. So this becomes x plus 1, x plus 2. So x plus 1 equals 0, x plus 2 equals 0, x can equal negative 1, or x can equal negative 2. In that second example, I have to move something over. So I'm left with n squared plus 7n plus 10 equals 0. I'm looking for factors of 10 that add up to be positive 7, which would be 2 and 5. So this becomes n plus 2, n plus 5. So set them equal to 0. N equals negative 2, and n equals negative 5. So solving by factoring is really one of the easiest ways to do it, especially if you don't have a calculator.